Okay, F is stand for initiator efficiency. Since the BPO is the most stable, so it dissolves in organic solvent, and in most monomer, they are suitable for solution or bulk polymerization. Second types of initiator is azo compound. So azo compound most commonly used are those having cyano group, which decompose at low temperature. Types of azo compound is AIBN. So AIBN stand for azo bicyso butyronitril. So cukup hanya korang tulis AIBN pun dah okay. So the reaction temperature at 60 degrees C by thermal or UV decomposition more stable than BPO, and because of the releasing of nitrogen, which is inert gas. So because of the stable, it cannot disrupt the reaction process. And the efficiency of the initiator is about 0.6. For redox initiator is the production of free radical by one electron transfer reaction. It is useful in the initiation process at low temperature and emulsion polymerization. Emulsion polymerization is one of the technique to produce paint. Kita buat cat pakai emulsion polymerization technique. Advantages of redox initiators, reaction rates are easy to control by varying the concentration of metal ion or peroxide. Okay, the fourth one is the photoinitiator. Peroxide and azo compound dissociate photolytically as well as thermally. So the advantages of photoinitiator, the reaction is independent of temperature. Okay, means that the polymerization may be conducted even at low temperature. It has a better control of, as you can see in this reaction, iron 2, which is Fe2 plus, has the oxidation number 2. And then after the oxidation process, F2 plus, the oxidation number increased from 2 plus to 3 plus here. Means that one electron here, okay, is releasing during the oxidation number. So it said that the oxidized metal Fe3 plus is reduced again to the Fe2 plus state by the hydrogen to form peroxy radical and a proton. Only a very small amount of Fe2 plus ion is required to generate the radicals. So same goes with this reaction. This oxidation number increase also from 2 plus to 3 plus by releasing one of electron here to here during oxidation. So if the oxidation process, it involves the releasing of the electron. Electron transfer reaction involving peroxide, persulfate, and metallic ions. Some are water soluble, suitable for use in emulsion polymerization. Okay, this is also same goes to this reaction, but the difference with previous slide is the use of the peroxide and also the ion, metallic ion here. Okay. Example of monomer that undergo the radical polymerization are styrene, vinyl acetate, NMA, vinyl chloride, acrylonitrile, 1,3-butadiene. So basically, if the question, final exam question, it can ask any of this monomer or other monomer that not displayed here. Okay, we will look at the polymerization mechanism. So this is the quite tough part. So I'm gonna show you a simple video, but the video is quite disrupt. Okay, but for the beginning, we start with the initiation process. Okay. Okay, initiation process begin with dissociation first. Okay. Sorry kalau gambar ni macam agak talent sikit, saya tak reti nak rotate video ni. Okay, we start with the initiation by dissociation. Semua chain polymerization dia mesti start dengan dissociation dulu. So, the general equation is I, arrow here to produce 2I. So, for example, we use this structure is BPO structure. Okay, you must draw the BPO structure first with the KD. KD is rate constant of dissociation to form two radical species. Okay, BPO structure dia akan break dekat tengah-tengah ni antara O dengan O ni, and then it will form two radical species. And then in the initiation by association, second step, awak hanya perlu lukis satu structure radical species ni. Tak payah tulis nombor 2. Okay. So lukis structure C double bond O dengan active species ni. Jangan tinggal dia punya active species ni. Okay. For example, BPO react dengan polystyrene. Okay, dia mesti react dengan monomer yang ada double bond. So, awak lukis structure radical species BPO ni react dengan polystyrene. Okay, ada double bond. And then, with the arrow of rate constant of association. Okay. Ka is rate constant association. Okay. Okay. Dia punya reaction process dia, the product dia akan hasilkan initiator BPO by the addition of monomer to initiating radical. So the product is the monomer with the initiating radical. Dia tak jadi polimer lagi ni. Okay, yang ni adalah structure BPO tadi. Awak combine dengan structure monomer. Ni. So awak salin. So in chain polymerization, the number of atom remain the same. Semua sama. Cuma H2 yang dekat sini, ni CH ni, sorry bukan H2, CH, structure benzene. Kat hujung tu dia kena ada active site. Awak jangan tinggal active site dia. Okay. Next step, which is third step, is the propagation. During the propagation, awak salin balik produk daripada association ni, salin kat bawah ni untuk first, plus dengan monomer ni. Okay, dia akan react balik dengan monomer ni. So it is then the addition of monomer to the growing polymer radical. Yang ni kita panggil growing polymer radical. Sama juga dengan yang ni, growing polymer radical. Awak salin balik yang ni, tulis kat sini, and then awak react balik dengan monomer. So the product is the growing polymer radical. Okay. Cuma dia jadi macam makin panjang lah sikit sebab dia dah propagate and the presence of the X. Okay, X number. So the same method, salin balik yang dekat depan ni, salin semua. Okay. Okay, by make it make a bracket here, and then with the x number of propagation. Then continue with the addition of monomer styrene at the end of the chain. Don't forget the active site here. Okay. So this CH2CH come from this monomer. Dia akan jadi makin panjang lah sikit reaction ni. Okay, propagation can be either head to tail or head to head. Okay. Okay, kita sambung dengan slide ni. During the propagation step in vinyl polymerization, okay, monomer tend to have the placement head to tail, where the more substituted carbon atom is designated as the head. So head-to-head placement may occur, but for example, during termination by combination, okay, as we'll discuss in the next session. Okay, two possible mode of propagation. Okay, we can look at these two possible mode. Okay, structure yang kita lukis tadi. Okay, ini adalah structure daripada propagation yang kita dapat tadi. Daripada rate of initiation by association, kita dapat structure, kita dapat structure yang ini. CH2CH kan, kita dapat structure ni, dia react dengan monomer tadi kan. And then kita akan dapat produk yang macam ni. Yang last video tadi saya tunjuk, kita dapat structure ni. CO, CH2 salin balik yang ni, CH, okay. And then repeat balik. CH, CH, CH. So this three is a tail to tail placement. Macam mana nak tahu dia punya tail to tail placement? So awak tengok CH2, CH ni adalah satu monomer, betul tak? So CH2, CH yang ni second monomer jugalah. Pertemuan yang kedua antara monomer ni dengan monomer ni, dia ditemukan oleh C ni dengan C ini. Awak tengok dua ni, dia punya styrene ni, dia alternate. Okay. CH, lepas tu CH2, dia alternate. Sama juga dengan yang ni. Apa beza structure ni dengan structure ni? Dia sebenarnya, beza dia, location styrene ni. Untuk yang ni, location styrene ni, dia letak dekat depan. Di mana CH2 ni duduk, CH2 letak kat sini. Maknanya daripada sini lagi, styrene ni duduk kat sini. Okay. So yang kat depan ni, structure ni sebenarnya styrene ni dekat sini kat depan. Untuk structure yang kedua ni, structure yang become to Roman ni, styrene dia duduk dekat ni lah, styrene berada di sini. That's why dia punya produk dapat macam ni. So sebenarnya structure styrene ini duduk dekat sini. And then untuk structure product 1 ni, styrene dia sebenarnya dia react styrene dia dekat sini. So dia dapat macam ni. It is the same structure, but the final arrangement of the monomer unit in which the substituent are on alternate carbon. The substituent yang ni lah dia memang alternate. Okay, faham ke tak ni? So this is, we call it as a head to tail, bukan tail to tail. Dia adalah head to tail. Maknanya ni adalah head, yang ni tail. Okay. So head to tail, kalau head to head, kita panggil 1-2 placement. Kalau head to tail, dia adalah 1-3 placement. Kenapa 1-3? Carbon number 1, 1. And carbon number 2, 2. Dia berjumpa balik dekat carbon number 3. Maknanya head to tail. 1, 3. Okay. 1-3 placement. Okay, two possible modes of propagation.